So, Namaskar and welcome to the webinar on advances in tsunami science and disaster risk reduction. To mark the occasion of the World Tsunami Awareness Day, that is 5th November, and this program is jointly organized by NIDM and INCOIS. Myself, Dr. Hachit Kaur, and I am the junior consultant in NIDM, and I will be the moderator and coordinator for this program. So, as we know that tsunami are among the most devastating natural disasters, though they may be rare, they know no coastal borders. Coastal communities, often concentrated in low-lying and highly populated areas, are the most potentially vulnerable to coastal hazards, including tsunami, with heavy human and economic losses. International cooperation is key for deeper political and public understanding, as well as involvement in reducing our risk from these coastal natural hazards. In December 2015, the United Nations General Assembly designated 5th November as a World Tsunami Awareness Day to promote a global culture of tsunami awareness. And the date for the annual celebration was chosen in the honor of the Japanese Inamuraha no Hi, meaning the burning of rice seeds. During an 1854 earthquake, a farmer saw the tide receding, a sign of a looming tsunami, and set fire to his entire harvest to warn the villagers, who fled to high ground, and afterwards he built an embankment and planted trees as a buffer against future waves. So the World Tsunami Awareness Day aims to raise awareness of tsunami risk and share the innovative approaches to reduce their impact. And here we are gathered to discuss about the recent advances in tsunami sciences in our country. Now, to raise the curtain of our inaugural session, I would request Professor Surya Prakash, Head of Geometeorological Risk Management Division, CBRN, Industrial and Cyber DRR Division, for the special address. Sir is doctorate in the field of earth sciences. He pursued his career at CBRI, IITR, JNU, Wadia Institute of Himalayan Geology, FRI, VIT. And sir written more than 30 papers in a reputed journal. So now I would request Professor Surya Prakash for his special address. Over to you, sir.
Thank you, Dr. Harjit. Good afternoon to all the distinguished dignitaries of the inaugural program, delegates and the participants, along with our organizing team from NIDM and INQUIS, our distinguished speakers of today's webinar. This is an important day in terms of the geohazards, which we are dealing as part of a geometeorological risk management division, and particularly focusing on coastal disaster risk reduction and resilience. NIDM has got a specialized center on this, and we are also working on early warning and communication on these hazards. And a lot of such tsunami events have happened in the past. As per one of the studies, more than 58 tsunami events have happened in the last 100 years, last century, and many of them has actually taken a huge toll of lives. If you talk back to the Indian Ocean tsunami, which took place on 26th December 2004, it actually affected more than 11 countries and engulfed about more than 227,000 human lives, 227,000 human lives in many of the countries adjacent to the Indian Ocean, and also lying in the low-lying areas, situated in the low-lying areas of the coastal belts around these Indian Ocean. So these have been happening in the past also, particularly in the Pacific Ocean region, and Japan specifically had faced a number of tsunami I remember the 11th March 2011 in the afternoon when the major tsunami took place at Sandai, and it was generated by an earthquake leading further to a nuclear disaster as well, termed as a triple disaster in Japan. Actually brought a lot of new lessons for our scientific and engineering communities as well as the DM authorities. It was perceived that although they were able to manage well the consequences of high magnitude earthquakes, but they were not well prepared against high intensity of tsunami which had happened at that time. Although they had made preparations by construction of seawalls and intermediary interventions uh, to cover small scale tsunami, but this kind of tsunami which had brought about more than 30 feet height of tsunami wave was much higher than expected by the scientists. So therefore, it brought a huge toll of human lives, and they started preparing against this kind of uncertain and unknown events also. So Japan was preparing, and it held, in fact, long back since 1990s. In December 1989, when the UN declared the IDNDR, International Decade for Natural Disaster Reduction, Japan was the first country to initiate the World Conference on Disaster Risk Reduction. First was held at Yokohama, and then the second at Hyogo, and the third one was held at Sendai, where the tsunami had affected. And I had the opportunity to actually witness the area before the tsunami and after the tsunami, and we could see that they took up all the initiatives under the fourth priority action and for the Sendai framework for disaster risk reduction as build back better. I'm sorry, I'm old, so they took all the precautions so that they are not affected in future by such events. And also with the Third World Conference, which was held from 14th to 18th of March 2015, it was followed by a discussion at the United Nations by the Japanese government to initiate a World Tsunami Awareness Day. In December, it was decided, and from that time onwards, every year 5th November has been observed as World Tsunami Awareness Day. In India, subsequent to the Indian Ocean tsunami, Government of India took the initiatives to establish a dedicated institute for this purpose, and the concept of inquest came in, and it was established, which built all the necessary infrastructures and also developed models to forecast tsunami. I remember yesterday I was participating in a World Landslide Forum, and we had a dedicated session on landslide induced tsunami. And this is also one of the areas, although our organizations are working well to predict the earthquake induced tsunami, but the landslide induced tsunami are also equally important. And to cover the coastal and the submarine landslide, which can also result into tsunami, would be one of those areas which also require attention from our scientific community. On the other hand, it cannot be a single stakeholder task, because all others have to collaborate, and collaboration is actually the key to strengthen governance in disaster risk reduction. And this year, the United Nations, on the day of International Day for Disaster Reduction, the sixth target F was there to support and encourage and promote international collaborations to strengthen national and local level initiatives on disaster risk reduction and resilience. So all these organizations are now working together, not only at the state and national levels, but also at the international levels. I remember way back in 2004, I had a chance to meet the director of Pacific Tsunami Warning Center, and we were discussing about how to take these issues in the Indian Ocean also. At that time, that tsunami had not happened in the Indian Ocean, and since there were very few who knew about the tsunami in the countries around the Indian Ocean, and it was not actually getting a due attention. But subsequent to the occurrence of that Indian Ocean tsunami, several of the DM authorities, they have taken up the initiatives and did all their scientific, engineering, technological, social, administrative, and legal works to manage the risks and reduce the exposure to the tsunami impacts. Because if we are able to, as said in the Glasgow meeting recently by our Honorable Prime Minister, go for the disaster resilient infrastructure, particularly for the island states and nations, which are getting more exposed due to changing climatic conditions, due to rise in the sea level, water, and also the impacts of the likely tsunamis around them. And because they are geographically confined and restricted, so they are likely to exposed to these consequences more than others. So therefore, all these nations, particularly the island nations, need to prepare themselves against the tsunami impacts and find their ways to respond quickly and efficiently to reduce the human casualties and damage and losses from the tsunami impacts. So number of attempts have been made, which includes even development of an early warning system using the buoys and various other geophysical instrumentations and satellite communication techniques, as well as we are also having now a common alert protocol to alert the public at large, and also to to instruct and prepare the different line departments who have to take immediate actions during a tsunami event. So mock exercises have also been done jointly at the international levels and at the national levels by the various organizations, particularly the states in the coastal states close to the Indian Ocean. So we must learn from each other whatever has been witnessed in other areas, particularly the Pacific Ocean area, where more of these kind of events have happened in the past. These should be taken. And recently, I remember there was a tsunami triggered by a landslide in Indonesia. So these kind of events are continuing to happen due to various regions, and we cannot actually stop these events to happen. But what we can do is reduce our exposure and also the impacts from these events by virtue of better land use planning, by protection and mitigation structures, and preparing people and against the consequences, as well as making them aware, informed through the community level outreach programs and advocacy of our policies, plans, guidelines, and procedures. So until as all citizens and communities, along with these scientists and engineers and administrators, are empowered, it will not be possible. As per National Policy on Disaster Management, as well as the Sendai Framework for Disaster Risk Reduction, we have to go for all-inclusive and ecosystem-based approach. And therefore, I wish all the best, and think that through these such programs, we'll be able to reach to the maximum possible number of people, and they would learn and implement the key lessons that have been learned from the recent historical events or the past events, and also devise different ways, including both the indigenous, local, traditional, as well as the state-of-art technologies. So until unless every person from the community is made aware and prepared against the risks from the tsunami, this kind of risk resilience against the potential risk would not be possible to achieve. So let's work together as a team. As it is said, together each achieve more, and we have to continue this approach in a sustained manner with the changing development conditions, land use changes, as well as the climatic conditions. So with these words, I would say thanks for providing me this opportunity and wish all the best for this program. Thank you. I would request finally the participants to do ask questions to make it bilateral and more useful. Thank you very much, Dr. Hachit. Back to you.
Thank you very much, sir, for sharing your words of wisdom with us. And sir, as we know that our institution and our government technical institute come up with practical and effective ways for awareness generation, even in the capacity building, education, training and research development. We are come up with a good techniques and understanding of this tsunami risk management. And even, sir, as you have told that NDMA has also developed a guideline for exploring the option for effective dissemination of a tsunami alert and warning messages generated by inquiries to the concerned agencies and coastal vulnerability communities exposed to tsunami in a coordinated manners. But sir, have a more detailed investigation on tsunami characteristics and their impact on failure of each type of facility is still needed to develop tools to support decision making for better emergency management to address the short and long term social impacts. Sir. Thank you very much, sir, for joining us. Sir. Now, moving ahead, we have joined by Director Inquires, Dr. Srinivasan Kumar. Sir has extensive research experience and held progressively senior techno-managerial position at premier scientific organizations such as Intergovernmental Oceanographic Commission of UNESCO, INCOES, Indian Space Research Organization, and all through his career, Sir has managed a large scientific project delivering high impact societal services, having lead their design, underpinning scientific foundation and implementation involving multiple national, international institutions, scientists, and end users. Sir was conferred with several national and international awards, including the prestigious National Geoscience Award in 2010 by the Ministry of Mines towards his contribution in establishing the world-class Tsunami Early Warning Center at INCOES. And he also received the Indian National Geo Special Award in 2008, instituted by Indian Society of Remote Sensing for his contribution towards application of geospatial technologies for disaster management. And Sir is recipient of Certificate of Merit given to Young Scientist for the year 2004 by the Department of Ocean Development, presently known as Ministry of Earth Sciences. And Sir hold PhD in Marine Sciences, and his research interests include remote sensing, geospatial technologies, disaster risk reduction, marine resources, coastal zone management, and satellite oceanography. Sir is author of more than 70 scientific publications in international peer-reviewed journals and contributed chapters in 4 books. Now I would request to take on Sir to take on stage and enlighten our participants. Sir. Over to you, sir.
Thank you very much, Dr. Hachit Kaur. Good afternoon to you. Thank you for the generous introduction, and it is always a pleasure to be in these webinars along with NIDM. Dr. Professor Surya Prakash and other colleagues who are going to be on the panel today, technical discussions, Dr. Sunanda, Dr. Behra, and all the attendees of this webinar. A very good afternoon to all of you. Very good technical presentations are awaiting you. So I'll be very brief now. All of you know, and Dr. Surya Prakash and Dr. Kaur have already explained, what happened during the 2004 tsunami. Several tens of thousands of people lost their lives. In India itself, the loss of lives is close to about 14,000. And in the whole Indian Ocean, about 230,000 people lost their lives. this tsunami was by far the most disastrous in terms of loss of lives or property in the whole history. So after this, in Indian Ocean, of course, the tsunamis are very rare. So that's the reason in 2004, we never had a warning system in the Indian Ocean region, leave alone India, entire Indian Ocean region, there was no tsunami warning system. There was one operating in the Pacific, which was set up after the 1960 Chilean tsunami. So when this actual event happened in the Indian Ocean region, our knowledge of tsunamis was very less. And the hazard assessment was not done. It was not known. And then we didn't have a warning system. People did not know what to do. If a tsunami happens, people did not know how to identify the natural signs of a tsunami. And that was what led to so many deaths. After that event, Indian government established the tsunami early warning system. It was a multi-institutional project led by INCOIS. Now INCOIS hosts the National Tsunami Early Warning Center, which provides information, tsunami warnings, not only to India, but to about 25 Indian Ocean rim countries. So we have a proper mechanism by which now we can detect large earthquakes. We can monitor any tsunami waves generated by such earthquakes. We can model the tsunami waves, and we can tell in advance if a tsunami is going to hit a particular point in the coastline and when it would hit a particular point in the coastline. Now, the warning time after an earthquake and before the tsunami comes to our shores can vary. It can be between a few tens of minutes, about 10 to 20 minutes if you're very near source, or it could be about 2 to 3 hours if you're far source. It's not like cyclone where you have about 5 days, 6 days, etc. So the warning time and the response time is going to be very less. So which only means that you should have very efficient sensor networks, very efficient communication networks, very good mechanisms to model tsunamis in real time, and then disseminate this information to the public authorities as well as to the public, and then public need to react. So the upstream part of having a very strong upstream part of the warning system is equally important. It should be supported by equally strong downstream part. And the downstream, I mean the last mile, which I would like to now actually refer to as first mile, because that is where, it's going to be very important. Public should be able to receive the warnings. They should be able to understand the warnings. They should be able to respond appropriately to the warnings, and then they should be able to move to high ground, get out of the tsunami's way. So both these things are very important, the upstream and downstream. Now, coming to Tsunami Awareness Day itself, today, November 5th, is designated as the Tsunami Awareness Day. And we should take each and every opportunity to sensitize the public, make them aware of the tsunami threat. If they have a hazard, are there tsunami inundation maps? Are there evacuation routes? What they should do in the case of a tsunami warning? So all these things we should be able to sensitize people. And then this World Tsunami Awareness Day is one such opportunity where we should do everything possible to enhance the awareness of public to tsunamis. This year, the theme of this World Tsunami Awareness Day is basically the target F of the Sendai framework, which is to substantially enhance international cooperation in the developing countries through adequate and sustainable support to complement their national actions. So regional cooperation, international collaboration is actually something which is very important. That is the theme of today's event, the World Tsunami Awareness Day, and which is something in abundance. The international collaboration coordination in the sphere of tsunamis has been in abundance since the tsunami happened in 2004 in the Indian Ocean region. So there are frameworks, international intergovernmental frameworks, which are established by the Intergovernmental Oceanographic Commission of the UNESCO, through which all countries in the region, there are 28 Indian Ocean rim countries, all these countries work together and have established a system called the Indian Ocean Tsunami Warning and Mitigation Framework, which has established a regional system. INCOIS is one of the regional tsunami service providers along with Australia and Indonesia. And there is also a very strong collaboration in the downstream part, which is actually through programs such as Indian Ocean, IOC UNESCO Tsunami Ready. And these programs provide a very structured framework for us to enhance the capacities of people the downstream capacities of people to be prepared for a tsunami threat. So there is a colleague, there is Dr. Behra from OSDMA. I'm sure he'll talk a lot more about tsunami ready. So there is international collaboration both in the upstream and downstream parts. So in Odisha, 2 communities have been identified as tsunami ready last year by the UNESCO IOC, and Odisha is going in a big way to actually enhance the reach of these tsunami ready communities to other villages. And there are also initiatives by other states and islands in the country and in the Indian Ocean region to actually identify their communities as tsunami ready. So which will be a big boost to enhancing community resilience to tsunamis as well as to other oceanogenic hazards. So as part of this Ocean World Tsunami Awareness Day today, INCOIS has taken up a lot of initiatives. One is this important webinar along with NIDM on tsunami, enhancements in tsunami warnings, and then we are also under the Azadi Ka Amrit Mahotsav. We are also having plans to adapt a local school, to enhance their science, technology, and engineering capacities. And we have school teachers visit our warning center today to learn more about tsunamis. We are going to actually adapt a village in Andhra Pradesh to actually make them tsunami ready, build their indicators for becoming tsunami ready. We are doing a webinar with the Andhra Pradesh State Disaster Management Authorities later today. We have had school children visit the Tsunami Warning Center today. And then learn more about tsunamis from our scientists. So we're doing a variety of things today to enhance this tsunami awareness. We'll continue to mount efforts required to enhance both our upstream as well as the downstream parts. With these few words, I would like to thank NIDM for giving INCOIS an opportunity to be part of this webinar along with you, and also giving me an opportunity to speak a few words on this occasion. Thank you.
Thank you very much, sir, for joining us and sharing your experience with our participant. Sir rightly pointed out critical issues that hinders the efficient and timely implementation and operation of early warning system is a lack of consideration or recognition of vulnerable groups. As sir said, this day aligns its aim with the International Day for DRR and the SFDRR interlinkage between disaster risk reduction, climate change, and sustainable development goals. So thank you very much for joining us despite your busy schedule, sir.
Thank you.
Thank you, sir. Now moving ahead for our technical session. Before start our technical session, I would request our participant please use Q&A window or a chat box for raising your question, query, or a concern relevant to the presentation. For our first presentation, we have with us Ms. M.V. Sunanda, who is working as a scientist at Indian National Center for Ocean Information Services, Ministry of Earth Sciences, Government of India. Her broad research areas include plate tectonics, subduction zone earthquake mechanism, tsunami generation, propagation, and disaster management. She has been representing INCOIS at the Intergovernmental Coordination Group for the Indian Ocean Tsunami Warning and Mitigation System. Currently, she is Vice Chair of Sub-Regional Working Group for the Northwest Indian Ocean. Ms. Sunanda has been involved with UNESCO IOC Tsunami Ready since it was first piloted in the Indian Ocean region, and ma'am is passionate about the expansion of the program. And she is a versatile person with a notable career and proven track record of 12 years at INCOIS. For her significant contribution to Indian Tsunami Early Warning System, she was awarded National Geoscience Award for the year 2010 and prestigious Young Achiever Award for 2016, which is given once in a year, 4 years. And today, ma'am will be discussing about the tsunami monitoring, early warning, and recent advancement and a way ahead. So now I would request ma'am to take on stage. Over to you, ma'am.
Thank you so much, Hershey. Can you please enable the share? Oh yeah, I got it. I hope it is visible now.
Yes, ma'am.
Thank you so much. So good afternoon, everyone. And thank you for giving me this opportunity today to talk about these advances in tsunami sciences and its disaster risk reduction. I'll give a brief introduction about like what is the difference between a normal wave and a tsunami and threat to India. How do we monitor at a tsunami warning center? What are the limitations and challenges we face while monitoring the tsunami early warning system? And how do we overcome them, like mostly using the recent technologies? And most importantly, what is community role in this whole process? So let's start. As you are aware, like more than 72% of the earth is covered with water, and 3/4 of the countries in the world have these coastal areas. And like one of the other oceanic hazard is very eminent for all these regions. So if we take the Indian Ocean, it has around 40 countries, and unfortunately, most of them are like developing countries. In India, we were worst hit by 2004 tsunami with so many losses, has been already informed by Dr. Srinivasan and Dr. Surya Prakash. So just to brief about like what is tsunami. A tsunami is like a series of catastrophic waves generated by the displacement of large volume of water. The major reasons for that are like undersea or the near coast earthquakes, or near coastal submarine landslide, or flank collapse due to the volcanic eruption, or the meteorite impact. Though these are all the reasons that 80% of the tsunamis are caused by the undersea earthquakes, as you see in this chart. So now what is the difference between a normal wave and the tsunami wave? The tsunami waves have a long wavelength with a with period of about a few minutes to so many hours. And they have this travel time at the speed of 500 kilometers to 1,000 kilometers in the open ocean, and they don't lose energy during this whole period. But when they reach to the coast, their height rises and into like tens of meters, causing this enormous destruction. As I said, 80%, 81% of the tsunamis were caused by the earthquakes. I would like to emphasize like that not all big earthquakes generate tsunamis. The earthquake must displace a sea flow vertically. That whole volume of the water is going to displace in this process. That is going to generate a tsunami. And as you see here in this table, there are several thousands of earthquakes generated annually, like less than a magnitude of 4. But we feel them only when the magnitude exceeds mostly 4. And there are more tsunami-genic earthquakes if the magnitude is exceeding the 6.5, which are usually around the 20 per year all around the globe. And where are these regions which can generate such major earthquakes, which can produce this tsunami-genic? This is India has a threat from these two known regions, which are called the Sunda Subduction Zone, and the other one is a Makran Subduction Zone, which is in the northern Arabian Sea near the southern Iran and the Pakistan. So as you see here, there are several major tsunami-genic earthquakes that have been occurred in this region. So this is like the risk from these zones is as studied. If any earthquake happens near Makran subduction zone, it takes 2 to 3 hours to reach the nearest Indian coast, which is usually Gujarat. And if we take the Sumatra subduction zone, it takes only 20 to 30 minutes to reach Andaman Nicobar Islands, and 2 to 3 hours to Indian mainland. As you can observe here, tsunamis are not like any other natural disasters which give us more time, like cyclones, 2-3 days to prepare ourselves. It gives only a few minutes to hours time for us to prepare. So it is extremely difficult to evacuate the whole post which is under threat within these 2-3 hours. And if you take the case of the Andaman Nicobar Islands, it is extremely impossible for them to put all these people into the high ground within this 20 minutes of time. So in order to detect such tsunami-genic earthquakes for the tsunami early warning system, we require a dense observation network with the seismic stations so that we can detect the earthquake as soon as possible of its occurrence, and the sea level equipment for confirmation of the tsunami generation. And these are the global network which currently we are using at INCOIS. And this is the national network at Indian Warning Center. We are using about 50 Indian seismic stations where we have 17 stations dedicated for the tsunami early warning, and the other stations which we take from the National Center for Seismology for improving our earthquake detection. And we also receive, as shown in the previous slide, around 350 international seismic stations also. And we monitor the sea level changes. We use for that 7 tsunami buoys, 5 in the Bay of Bengal and 2 near the Northern Arabian Sea, and 36 tide gauge stations. And as I said, we receive the international stations also along with that to improve our observation network. And after detecting such earthquake, then when we want to issue the bulletin, we should have the information about what's the estimated tsunami travel time and what's the tsunami wave height. So in order to get these forecast details, we have a pre-computed scenario of 7.5 magnitude earthquake, and as and when any earthquake occurs of any magnitude, whether it is 8 or maybe 7, what we do is like we scale up or scale down using these scientific relations, this magnitude, and then we match the real magnitude and issue the threat assessment details for all the coastal forecast zones. These coastal forecast zones are nothing but the coastal district boundaries, how we have rendered. And to issue such bulletins, we follow a standard operating procedure where we commence our services with a trigger of earthquake magnitude 6.5 in the Indian Ocean and 8 in the other oceans. For that, our SOP is like this SOP is very uniquely designed to address both the near source and the far source regions. For example, if any earthquake occurs at the Sumatra subduction zone, the Andaman Nicobar Islands will be very near to the source. So in such case, we directly put them under warning. So where they get enough time, at least for the evacuation. And in case of the far source, which is like we consider the Indian mainland, for them, we do have at least this time compared with the Andaman Nicobar Islands. So we wait for the confirmation from the sea level sensors, such as the tsunami buoys, which are placed in the open ocean at the nearby tide gauges. Maybe like if the earthquake happened in the Indonesia, that must have been first hit. So we see the tide gauges over there, and then the Andaman Nicobar Islands also for this confirmation of generation of the tsunami. And this will reduce like a great amount of false alarms, considering both the near source and the far source regions separately. And there are 3 levels of tsunami threat in our bulletins: warning, alert, and watch. When warning is issued, the public must be evacuated from the low-lying areas to high grounds, and mostly from the vulnerable coast also. And if it is an alert, the public are evacuated from the beaches and move to the higher grounds. And if it is a watch, it's only heads-up message from the inquiries to the all disaster management officials, so that they could be on alert for the next incoming information from the warning center. Maybe that would get level up, and maybe it could reach to the after confirmation of the tsunami, it can go to the alert or to the warning also. So these products, what we generate includes the notification messages, which has the link to our website from where you can find all the detailed information of the bulletins, which consider consider having the graphics for easy understanding of disaster management officials. We do have the information, even the spatial data also, like on request, we can provide them out. That would be easy for them to see what are the areas under threat on their own desktop. And as Indian Tsunami Warning Center not only acts as the national Tsunami Warning Center, we are responsible for providing the bulletins to whole Indian Ocean Rim countries as part of our role as a tsunami service provider for the Indian Ocean region. And we disseminate all these bulletins nationally, what we are disseminating to all the concerned ministries, state disaster management officials, like principal secretaries who are responsible for the disaster management, and some important establishments such as nuclear power plants. Just in brief, this is what I have explained in my all previous slides. What we do at Warning Center is receive the information from the several observation networks through different kind of communication modes, and then we analyze the data at various levels to generate the bulletins, and we disseminate this information to the public. On the other hand, we also actively organize and participate in several tsunami awareness and preparedness workshops, and we do many research and development activities also at inquiries to improve ourselves. So let's start with the challenges what we face at the Tsunami Warning Center. As I explained earlier, like we do need seismic sea level gauges for monitoring the tsunami, but these sensors come with their own limitations. For example, the near source broadband seismometers will get saturated for the major earthquakes. That means they go overscale. So we have to depend on far field stations, which provide us the long period waves for estimation of actual displacement to see whether it's a vertical displacement or the horizontal displacement. And which is actually very much important for us for the initial forecast to give what is the estimate of the wave. And the sea level sensors, such as the tsunami buoys, are very expensive, and they are prone to vandalism. And the tide gauge network is like very sparse, and they are also exposed to damage from the cyclones and the storms. And what is like the major challenges apart from this observation network is a few cases I would like to give an example. This is the first case of the Japan tsunami of 2011. The major issue here was the underestimation of the magnitude due to the reason which I explained. Like when they used only the seismic data, they got saturated and they got the estimate of magnitude 7.9. But which was like after revising after several minutes, they found it like it is around 9 magnitude, and by that time the waves have already devastated several coasts of Japan. And this is the second case of the 2012 April 11th tsunami. It was very minor, only 30 centimeters was observed at the Campbell Bay. But as I said before, after detection of an earthquake, we have to issue this tsunami forecast as soon as possible. So what we do is like we consider it as a worst case, assume that it's a vertical displacement. So when we did that, we found that the Andaman Nicobar Islands were going to hit by a wave of greater than 2 meters. But after analyzing the data, which came later on, so we found that it is a horizontal displacement. That's why it generated a minor tsunami. So this is like a kind of another challenge for us for the early detection of what kind of a displacement it took place in the beginning itself. And this is a 2013 case of Balochistan earthquake. This happened around 200 kilometers away from the coast. Like, we consider it as an inland, but this also generated a tsunami. Though it was a minor tsunami, the reason was like kind of inexplicable. After the earthquake, a new island emerged from the ocean near the southern coast of the Pakistan. And this has put us in a strange situation to deal with. And this is a last case I would like to emphasize is like tsunamis. As I said, like 81% of the tsunamis are generated by earthquakes, but this is two tsunamis which happened in 2018 in Indonesia. Very rare cases. These tsunamis one was triggered by the submarine landslide after an earthquake, and the other was by the flank collapse of the Anak Krakatau volcano. During this Palu tsunami, several landslides were triggered, and around 2,100 people were killed. And during the second tsunami, due to the Anak Krakatau volcano, about 430 casualties are found. So, and you can see the magnitude here is only the 3.4, which is like not a criteria for us to commence our tsunami services. Though there was no regional destruction because of these two events, these waves reached the near source, like we call them as a local tsunamis, within a very few minutes. So this Palu tsunami, we have seen a video like this tsunami reached within 3 minutes after the origin of the earthquake. So there is no time for anybody to even warn. To summarize what I've said, all the gaps, what we have found, like in the upstream, we have the gaps in the tsunami hazard assessment, and we have to reduce like uncertainties at many folds, and we should monitor now these atypical sources. Right now we are monitoring the earthquake triggered tsunamis in the whole world, I would say, because everybody is right now looking forward to generate their standard operating procedures for these atypical tsunamis, such as tsunamis generated by the volcanoes and submarine landslides. And we would like to improve the warning chain levels, warning chain at all levels. And taking the downstream part, there is a very less knowledge about the tsunami risk in coastal communities. For example, in the western coast, if you take, I think there would be very less people would be knowing they are prone to the tsunami from a Makran subduction zone. And there's again a false sense of security based on mostly like they haven't experienced any such kind of a disaster. And another like what we have seen in Palu tsunami is also like mostly people usually see the reaction of the neighbors, and if they are not evacuating, and why we should get evacuated. So that's how they are like a kind of a false confidence. They are safe from the tsunami. So that's how they feel. So, and most importantly, there is no preparedness in these communities. So, how to fill these gaps? So first I would talk about the upstream part and how we are able to manage using the recent advances in the tsunami science, and then we'll go to the downstream. So here, this is a way to know the seafloor displacement at the earliest by using this GNSS and SMA network. they measure the displacement directly. So rather we wait for the long period seismic waves from faraway stations. We can directly use this data, analyze it to get the displacement. So what's a displacement in the seafloor, whether it's a vertical, whether it's a horizontal, and how many meters it has moved. And we are currently establishing such kind of a network in the Andaman Nicobar Islands, which lies right on the subduction zone, so that we can measure these sea floor displacements directly. So this will improve our warning system tremendously, I would say, just by warning time, and the forecast results also would be improved most drastically. And this is using the sea level data to characterize the source, which is like to see what extent the rupture has taken place and in which direction the rupture is moving. Also, it helps us to identify the source of the tsunami, source region where it has actually generated. Like in this case of the 2013 Balochistan earthquake, as I said, the earthquake was 200 kilometers inland, but still there was a tsunami. So with this kind of inversion of the data, we were able to find out where is this location of this generation of the tsunami. And using this high frequency coastal radar network, we have established this network to monitor actually the currents in the ocean for early detection of the tsunamis. Also, we are using now. There's an example of 2012 earthquake which generated the minor tsunami, and we were able to monitor this tsunami also using this, of course, Andaman Nicobar Islands HF radars. And it is not only important to characterize the tsunami with this limited data and many uncertainties what we face at the initial stage, we also under tremendous time constraint first initial stage. So that was the reason for creating a pre-computed scenario database for the early forecast, so that we can have a readily available information showing a kind of earthquake which would have happened in that region. But now at INCOIS, we are capable of generating the tsunami forecast in real time with using there's high performance computational facilities which are available at INCOIS now. This is an example of the 2004 tsunami simulation compared with the real-time real observations. We found that this is we can take for the operationalize. And the tsunamis are rare, as we have been talking about this so many times. So in order to sustain this knowledge and operations related to tsunami, we need to integrate it with the multi-hazard assessments. At INCOIS, we have carried out such multi-hazard mapping using the parameters such as sea level change, extreme weather events. And these results are integrated with the realistic 3D visuals along with the socio-economic data, so that when the disaster management officials, they can even identify the individuals living at the particular selected address. So this is, we are going to take further for all the most vulnerable coasts. This is like the emerging technologies where how we can use this telecommunication cables, which are called like science monitoring and reliable telecommunication cables for monitoring not only for the tsunamis, any other ocean state related parameters. This is in collaboration with the industry partners like the telecommunication providers. We would host several sensors and their cables, which would be able to give us a real-time information about the current state. considering this a vast network of the undersea cable right now going on around the world, this will improve our observation network tremendously. And this is another way of partnering with the oil and gas industry. We have several such platforms, oil platforms around the world in the open ocean, and these are very useful for mounting ocean mounting sensors in these kind of open ocean conditions, which actually, if we take for ourselves, like for INCOIS itself, we have to have many kind of strategies and logistics to follow to go this open ocean. So if we have a partnership with this oil gas industry, we can achieve these ocean monitoring capabilities at a very low cost compared with what we face directly with these logistic issues. And this is another platform which we can use the ships as the GNSS sensors. This is also, I would say, a low-cost dense network. Like for example, on any time, around 15,000 ships are actively are going in the ocean. So if we equip only the 10% of them, then we can increase our network, this ocean observation network, tremendously using these additional GNSS stations. This is an example of the ship Kilomona, which could detect a tsunami in open ocean, which was like only the 10 centimeters. But if we have that kind of a network in the whole open ocean, we can detect the tsunami generation at a very early stage. This is a satellite altimetry, another emerging technology, which is used like directly, which is used to measure the sea level directly. Like at least 2 satellites will be in view at any point of time for measuring the sea level. So like in 2004, we had the Poseidon, Envisat, and the JSON-1 satellites, which provided the real wave heights of the tsunami. And in March 2011, we had another 3 set of satellites which also provided this generation information of the tsunami. And it is very advantageous because we can cover both spatially and temporally. And this is the airborne observation. So this is also the similar kind of satellite altimetry. We would be able to equip these commercial aircrafts with the radar altimeters. And considering several, like almost thousands of airports are near to the coast in the world. So if we equip them with at least a few with this kind of sensors, these radars, we could again build a very dense network of sea level. And this is ionospheric observations, as I said, by using the GNSS dense network. This is also one kind of advantage we'll have. They play a crucial role for identifying the tsunami perturbations in the atmosphere. Like this long period ocean waves, usually they transfer a certain amount of the energy to the surrounding air, which usually after reaching around 300 kilometers in the atmosphere, they create pulses which could be monitored using the GNSS data. So this is another advantage of equipping all the ocean oil and gas platforms or the ships with the GNSS sensors. So we could get many outputs for the tsunami early. And this is under technology, which is infrasound equipment, which can log the inaudible frequencies emitted by the earth layers and the traveling tsunamis. Like even in Anak Krakatau earthquake, such sounds were recorded as shown in this picture. And we can come up with some procedures to include such infrasound in our triggering mechanism for the tsunami early warning system. And there's a new opportunities called the Tsunami Program, which is an initiation by UNESCO as part of Ocean Decade. This tsunami program is it has two aspects. The first aspect is to explore the technological and observational advances, and the second one is have this capacity building, improve the community awareness and preparedness, and make these vulnerable communities 100% tsunami ready. So what we are seeing in this graph is like, as you see here in 2004, we had very less observation sensors, and rarely they were like in real time. So our detection and forecast capability was around 45 minutes, which is like a very pathetic in case if we consider the 2004 tsunami, where the wave reached within the 20 minutes. In 2019, we have come a long way to achieve it to 15 minutes. 45 minutes to 15 minutes is also a very good time now for the detection and the forecast. But our target with these new observational technologies is like 10 minutes. So this could be possible with the addition of many sensors and improving our capabilities to provide realistic advisories. And as I said before, if we consider the downstream part, which is equally important for building a tsunami resilient community, we must involve them and make them as the central figure. So the Tsunami Ready is one such program. The main goal of this program is to improve the coastal preparedness and minimize the loss. When that program was initiated by the UNESCO, we were very happy that Odisha came forward, and they took this as a pilot basis and they implemented it in the 6 coastal villages. And I'm very happy to inform that the 2 of them were visited by the UNESCO's team, and they recognized them as the tsunami ready communities. And India is the first country in whole Indian Ocean to achieve this capability, and Odisha is the first state in India. And this is my last slide. This is just to emphasize what is important, what we do at the warning center. So our major tasks are like we would like to improve our capability to detect and monitor and disseminate tsunami advisories by greatly minimizing the uncertainties. On the other hand, we would also like to raise awareness and preparedness in collaboration with these disaster management agencies. And this is, as you know, like a perfect warning will be useless if people do not know what to do in case of emergency. So it is our responsibility to improve this awareness and preparedness at every level of stakeholders. So this is all. Thank you.
Thank you very much, ma'am.
Stop sharing
Yes.
this. Yeah.
Yes, sure. Ma'am, we will go ahead and take some or a few questions, ma'am, if you can permit, ma'am.
Yeah, sure.
Yes, ma'am. So, ma'am, there is a one question raised by Kumar Kesri. Could we do a probabilistic tsunami hazard analysis of different return periods and wave height and prepare the tsunami seismic microzonation map for coastal areas and tsunami shelter for local people? Ma'am, you can also read this question from chat box. Yes, ma'am.
Okay. So Yes, we can do this probabilistic tsunami hazard analysis. Currently, we have already initiated this work at the inquiries. Initially, we had a deterministic approach, and we have taken a few worst scenarios, and we did for the Indian coast. And now we are taking all the probable situations so that we can get the recurrence period of the major earthquakes and analyze this for the vulnerability of tsunami to the coastal communities.
Thank you, ma'am. And one more question is, I think, yeah, ma'am, question is, tsunami is too rare in Indian coast. Is there any possibility to increase the number of occurrences?
Get its occurrences is no, it's not at anybody's hands. It's a kind of like see, for example, if 2004 tsunami, if we take, there was a kind of in scientific community where we didn't expect that tsunami. And when it happened, it took everybody by surprise. And then when we analyzed it, we found there was a kind of tsunami in 1,000 years back. Similarly, in case of Makran subduction zone, there was like in 1008, there was a tsunami in the Makran subduction zone, and then in 1945 we had another tsunami. So we have to be like, they are rare. So that's the most concerning part here. They are rare, so we have to like maybe in another 1,000 years before, maybe another tsunami would have happened, which we couldn't find any historical evidence. So that kind of information, when we find, it is very important for us to see. Maybe tomorrow there is a chance of tsunami occurrence, the day after tomorrow there is, maybe even today also. So we have to be prepared for that and keep ourselves more
Thank you very much.
active.
Yes, ma'am. Thank you very much, ma'am, for addressing all the queries and concerns raised by our participant. And it looks like we have covered all the questions raised by our participants. So thanks again for joining us today, and we will see you next time also, ma'am. Thank you, ma'am.
Thank you. Thank you so much.
Yes, ma'am. Now moving ahead, we have joined by Mr. Meghnath Behra. He is a shelter management and community interface expert in OSDMA. Now I would request to sir to share his experience with our participants. Over to you, sir.
Thank you so much, Harjit. Please give me able me to share. Yeah. Yeah, my PPT is
Yes, sir.
visible. Okay.
Yes, sir. Your PPT is visible, sir.
Yeah, most of the scientific things has taken by and given a lot of idea by Dr. Sunanda. So thanks, Harjit, giving me an opportunity to share the Odisha experiences in preparing the community for to face the tsunami. So basically, this is the social aspect or disaster management aspect of tsunami readiness. How we are preparing the community to face any future tsunami or tsunami, as per our scientists told today or tomorrow or day after, anytime you can face any tsunami. So basically, in case of Odisha, we have a 480 kilometers coastline, and we have 328 villages in 12 blocks in 6 coastal districts are prone to tsunami. 5 urban local bodies also prone to tsunami. Around 3 lakh people, 3 lakh populations are tsunami prone, are living in the tsunami prone areas. 5 major tourist locations, including UNESCO heritage sites, are also tsunami areas, and 3 ports are also coming under the tsunami prone area. If you see that around 22 blocks, 115 gram panchayats and 328 villages, and 3 major urban local bodies are coming under the 6 coastal districts, and also they are very prone to tsunami. Our GIS experts developed the GIS mapping on tsunami hazard zones. So from these mappings, we have taken, we have selected 328 villages as tsunami prone, and whatever I have told in my last previous slides. Taking the 11 parameters of Indian Ocean Tsunami Ready program, that 11 indicators, we are preparing our community. Basically, have a community tsunami risk plan, designated map of our tsunami village inundation zones, a public display or tsunami information, everything. Whatever the 11 indicators, taking all the 11 indicators who are working for the community. So we'll, one by one, we'll go for what are the indicators and what we are doing for the community and how we're preparing them to face the future tsunami. Basically, today, the 5th November, I happily inform you all that we are conducting tsunami mock drill in around 70 villages and 3 urban local bodies. And just completing the tsunami mock drill, I am here on the way to Bhubaneswar. In a circuit house, I am discussing with you regarding our preparedness activities. The village level tsunami management plan, we have a village tsunami management plan for 328 villages and 3 urban local bodies. Basically, the district engaged NGO for preparation of the plan. NGO training organized by OSDMA for preparing the plan. Template developed and shared with the districts, and ward-wise, village-wise plans are prepared for 328 villages and 3 urban local bodies. You see that these are the plans, and the mostly important, we are giving the evacuation map of if tsunami occurs, where they will go, where they will go, and who take shelter. That is the most important thing, because you have only few minutes to evacuate yourself. That we are giving importance for our in our tsunami management plan. We have also organized training programs at different blocks, different district headquarters. We have organized to 22 TOT programs for different peoples. 3 tenors for tsunami prone villages. The 3 tenors we have trained, who will impart training to the NGOs, to the PRI members, to the SH members, to the school teachers. So master trainers are created by OSDMA. Through different training program, through different models. But during our training program, we have never forget that COVID protocol, COVID safety protocol we observed during our training. And all the training programs are completed. Now the master trainers are giving training to orientation to teachers. Around 1,000 schools in the coast. Though these teachers are trained. One teacher from each school are trained in the tsunami preparedness. And all the teachers who have trained, they are also educating their students in their corresponding schools. The state level master trainers are created for the teachers training, and in each and every, as it is a new normal, we are following the COVID protocol. Then capacity building of the SHG members, around 1,200 SHGs were identified for capacity building from the 328 villages. For the training of the SHG members, their master trainers are created by OSDMA, and they have imparted training on tsunami to the SHG members. I want to inform you that in Odisha we have around 70 lakhs SHG members, but in coastal around 536 lakhs, around 70,000, sorry, 67,000 SHG members who are trained in tsunami preparedness. Then school awareness program, the teachers who have trained in the district level training, they are the master trainers that imparting training in the school level. They're educating, they're creating awareness in the schools. You can see that the photographs how we are imparting training in the schools, and mostly, and also parents in the are also imparting training by our experts from Odisha OSDMA to create awareness, which was already Dr. Sunanda informed that there is less awareness among the people. So to bridge that gap, we are creating more and more awareness in all the stakeholders, in all the community members, taking from the little student, children up to the age group of 90. So how to create awareness on tsunami? That is our target. how to create the capacity of the community. They can respond to any disaster or specifically the tsunami. For responding the tsunami, the most important is reaching out to the community and communicating with the communities. We have 128 alert siren towers across the coastline. 58 satellite phones to given to the all the district magistrates. 14 early warning dissemination system and satellite-based mobile data voice terminals also set up in the coastal area. Quick deployment antenna also set up in different strategic places. Alert mass messaging system also we have developed, and 168 digital mobile radio set up to give early warning to the people. And also we have a decision support system. We are supporting us to take quick decision how to prepare the people and giving them information. As early as we can reach to the people, they can evacuate themselves. That is the most important thing for the. Then we have established a robust early warning system, and also we have test taking it regularly. In the fortnight also we are test taking, and the DOC block the district emergency operation center and block emergency officers are well equipped for early warning dissemination. Every fortnightly report on the operational condition of the EWS are sent to the Togostoma by the district authorities. So how the things are, the technology is working, that also regular basis we are looking at it. So if it is anything wrong, immediately we are taking step to repair it and keep it updated. And satellites, already I have told you that satellite phones are provided to all the collectors. A community also are trained to respond the warning. If something, if the siren is blow, so how they will respond, what they will do, where they will go, what is their responsibility, how they will inform the people after getting the early warning. So today morning I have seen after 3 rounds of siren, they have started to coming to the cyclone shelter, to the safe shelter. So now people are acquainted with the different technologies and they are and responding to it. That is most important. That way we are creating and building capacity of the community. Then distribution of IC metals, different IT metals in the vernacular language is distributed to the people, and mostly posters, leaflets, then some of the other form of IC metal also provided to the people to create awareness. That is most important in our mind to prepare the community for tsunami is to create awareness, and any form we want to reach to them. That's why we are taking a lot of initiatives to preparing the community, to building the capacity of the community. Then wall painting and tsunami signage, almost wall painting in completed in 328 villages. Basically, it is in Odia vernacular language. You are unable to read it, but it is for the community. That's why it is in Odia. And also you can see that tsunami signage, where they will go, where is their safe shelter. Even if the cyclone shelters or the multi-purpose flood shelters constructed between in between 1.5 kilometers, these are not safe. We are also preparing the community. We are also identified. The community also identified the safe shelters away from 1.5 kilometers. That's why the signage is given there, and they will follow the signage. And they have prepared that evacuation plan. Already I have shown you in that my previous slide. They know where to where they will go, which is their safe shelter if the tsunami warning comes. So that is most important. The signage is providing them the information where they will go. Here it's written the tsunami Ashray Stalaku Rasta. That means the tsunami evacuation route, where they will. But which place is safe for them during if the tsunami occurs. Then we are creating awareness among the people through Kala Jatha or street play. Basically, Kala Jatha is street play on tsunami awareness to be organized, already organized in all the villages. You can see that content developed and shared to the cultural troops. District identified the cultural troops for the activity. Culture to perform all the tsunami prone villages to create basically the local function like Daskatia, Pala, then some other forms, which is convenient to people to understand. That way we are creating awareness and preparing the community. Then creating community physical and social infrastructure. We have 900 plus shelters in in our 25 districts, but in coastal areas around 300-400 cyclone shelter, which is constructed for the cyclone shelter or flood shelters. But we are advising people not to go that if it is in between 1.5 kilometers, you don't take shelter. You go away 1.5 kilometers. Otherwise, it may be create 32 type of emergency equipments are given to the cyclone shelters, which will be helpful during the time of tsunami or any disaster to save their life. And managed by community-based organization, whatever the cyclone shelter, flood shelter, or the shelters identified for tsunami shelters, safe shelters, there is a secretary. They are managing. There is a community also. They are managing the shelters. 50 task force volunteers in each cyclone or flood shelters are trained on basic survival skills, and they can support the community at the community level before the response force reach to them. Proactive participation of women self-help group is our most advantage thing for us. The women are very active. I have seen around 100 women are participated in one village in Bhadra districts, and they know what to do. What is tsunami? How they have they can evacuate themselves, and where they can evacuate themselves, and how they will help the other members of the community. That is the most important thing what I seen today in the tsunami mock drill. And also the BDO, the panchayat, the sarpanch, the ward members, all are active. And today one sarpanch was giving a very good things to the people. He himself was creating awareness. What is tsunami? What they will do? Why people are gathered here? What is their role? What community will do? All these things, the sarpanch was so vocal to say to the people. It was amazing. I'm so happy to share with you that our community members, including our PRA members, the government officials, each and everybody knows about tsunami, even if the different techniques. That is most important. Safe shelters are identified away from 1.5 kilometers the sea coast. That is also I have told you. So in different ways, we have preparing the community to save their lives. Then we have also volunteers. Around 1,12,000 volunteers are trained in different aspects of disaster management, and they will be helpful to us during the time of the disaster or during the if the tsunami occurs. They definitely provide support to the community and save their life. Then mock drill, which is the most important thing. Already today we have conducted preparatory meeting at district level and block level. Our OSDM official visited 22 blocks, 6 districts to create for preparatory meeting. They have discussed all the block level officials what to do, how they will helpful to the community. After the preparatory meeting, the block level or district officers, the district level and block level officials also conducted preparatory meeting on GP and village level with the community. How they will prepare themselves. If siren blow, what they will do? How they will come to the shelter? Or where is their shelter? Or what they will bring with them? All these techniques, and even if the family survival kit, they also discuss with them. How they will survive, or at least what they will bring with them, like the dry food, some materials, certificates, bank account. Within half an hour, what is possible they can bring with them and save their life. And today we have conducted the mock drill. Mock drill basically is a practice drill, is a rehearsal, is a stage rehearsal before any disasters. So we received the message from inquiries at 9:30. Then after 9:30, the message directly go to the villagers, the block officers, the collect district emergency officers, and then the siren blown. and people started to evacuating themselves. And then taken that is around 20-25 minutes to evacuate the whole villagers. I have seen around 150 people are evacuated today in one village, that is Mohanpur. So then after the evacuation, people gathered one place. Then they have counted themselves. Then some volunteers who are trained in the first aid, search and rescue, they have demonstrated. And some volunteers also given some information to the villagers, what is tsunami, what to do. Then in that meeting, block level officials, district level officials, state representatives were present. I was observing as a state representative what they're doing. Whatever we have trained them, actually they are doing it, or they're able to perform it or not. That was the most important thing. And what I have observed, everything was good. People were so trained and used to mock drill, uh, used to conduct a mock drill. It was a nice thing happened today. So not only in where I have visited, but all the 70 villages and 3 urban local bodies, wherever we have conducted mock drill, it was very, very interesting. And people was taking interest. That is most important. We are not. It is interesting for us. It is not important. Important that people are participating. People are, and one thing is that people know about the tsunami things, how to evacuate themselves, and then there is a common discussion among the people regarding tsunami, and then we have distributed some food dry food items to the people. Then de-warning started at 12:30. Then people started to move their village after some discussion. This is this is the way we are preparing the community tsunami threat. So already we have discussed that Odisha is the only state we have who has been recognized by UNESCO as the tsunami ready village. Thanks INCO's team, Dr. Srinivasan Kumar and his team. They have given a lot of support to Odisha government to prepare the community. And with their support, whatever the criteria, the indicators they have developed, we are following it only. We are following it up and preparing the community with their active support, with the active support of INCOS. We are trained the officers, the volunteers, and other people. I think if somebody will come and see our community about their capacity building, they can understand how we are preparing the people to face the tsunami. Thank you, all of you. This is all about our preparedness regarding tsunami preparedness. And now again, I am happy to say that 2 villages of Odisha, one is Venkatrayapur in Ganjam district, and one village in Noliasai in Jagatsinghpur, declare tsunami ready village. And we are planning all the 328 villages and 3 urban local bodies will be declared as tsunami ready. Thank you so much.
Thank you very much, sir. It was really a wonderful presentation. And sir highlighted the Tsunami Ready program that is implemented in Odisha. And sir also discussed the vulnerability of Odisha coast and how Odisha mapped the hazard zone for tsunami. So thank you very much, sir. Sir, as I have seen the chat box and in the QA window, there is no question raised by a participant, sir. Sir, then there is one question.
Yes.
Yeah. Sir, how we can educate the people regarding the tsunami preparedness, sir?
Yeah, basically we are preparing the community in different methodologies. We are through the local officials, through the master trainers, through volunteers, teachers, taking different steps. We are reaching to the community. We are preparing the community. That is the important things for us. And Hachit, I'm happy to say that today with the way we have reached the people, the mock drill conducted, it's really something is yes, we are doing something for the people.
Yes, sir.
So reaching to the community is not a one-day affair. It's a long process.
Yes.
through our disaster preparedness process, we are reaching the people. Otherwise, people will not believe us. So that's why we are mobilizing the community. This is the important way, the factor to prepare the community.
Yes. Thank you very much, sir, for addressing the
Any other
question
question?
raised by our participants. No, sir. Thank you very much, sir,
Okay.
for sharing your practical experience from Odisha. So thank you very much, sir, to joining
Yeah.
us despite your busy schedule, sir. Now moving ahead.
Thank you so much.
Yes, sir. Sure, sir. Now moving ahead, it's time for the summary of the webinar. So I will discuss about the summary of the webinar. So the first presentation was delivered by Dr. Sunanda from INCOIS. Ma'am discussed about the effective tsunami early warning system, which is achieved when all persons in vulnerable coastal communities are prepared and respond appropriately in a timely manner upon recognitions that a potentially destructive tsunami is approaching, and timely tsunami warning issued by a recognized tsunami warning center are essential. Ma'am also highlighted about the Tsunami Ready program that was implemented in India, and by discussing the vulnerability of Indian coastal states, and ma'am also enlightened about the Indian Ocean Tsunami Ready program for enhancing the coping capacity of coastal communities to tackle tsunami. And ma'am also discussed the tsunami forecast. And the second presentation was delivered by Mr. Behra from OSDMA. Sir discussed how Odisha mapped the tsunami hazard zone, followed by the tsunami training capacity development in tsunami-prone blocks of Odisha. And in the aftermath of the 26th December 2004, Indian Ocean Tsunami made excellent tsunami awareness material were developed especially at the country level to inform the public and the decision maker on tsunami hazards, risk, preparedness, and mitigations. So this webinar with the observance of the day, that is our World Tsunami Awareness Day, would help to spread awareness among the people across the country in matters related to the danger of tsunami, and shall stress on the importance of early warning system in order to mitigate the damage from the often devastating natural hazards. And it also aims at receiving traditional knowledge about the tsunami. So this is all about the summary of the webinar. And now moving ahead to our Valdixian session, there is one announcement that Professor Surya Prakash's health is not good, so he is not able to join us for the concluding remarks. So I will take the opportunity to propose the vote of thanks on behalf of NIDM and INCOIS. So first of all, my sincere gratitude goes out to ED NIDM Major General Manoj Kumar Bindal and Director INCOIS Dr. Srinivasa Kumar Tumala. By their blessings, supports, and grace, we are able to make the event successful. In addition, we are grateful to Professor Surya Prakash, Head GMR Division, NIDM, and who is the course chair of this webinar, for providing encouragement and support to organize this event. And our sincere thanks goes to our distinguished speakers, Ms. M.V. Sunanda, Scientist E INCOIS, and Mr. Meghnath Behra, Shelter Management and Community Interface Expert from OSDMA. And today we had the opportunity to hear your thoughts, and your thoughts have enlightened our minds and shown us a new path towards the tsunami risk reduction and resilience. And we would like to acknowledge our NIDM team, Dr. A.L. Haldar, Mr. Anil Katar, Dr. Raju Thapa, Mr. Hari, Ajit, Dipali, Balaji, Shobhit, for making this event successful. Thanks everyone for their participation and their willingness to complete the webinar beyond their comfort zone. Thank you very much. Stay safe, stay healthy. Now I'm ending the meeting. Thank you all.